Hey there, Math Hoppers! In this video lesson, we will learn how to solve linear systems using substitution. So a quick review of what a linear system is. Linear systems are simply two or more linear equations that are solved together. And in this video lesson, we will concentrate on linear systems with simply two equations. So since we are solving a system that will contain two equations, the point or the solution must be the point xy that works for both of the equations. It has to make both equations true. Remember that when we are solving linear equations, solutions are simply points along the graph of that line. So if we're solving a linear system with two equations, our solution needs to be a point on the line of both equations. Therefore, if we look at this linear system that's graphed, the solution is simply 2, 4, because that's where the two graphs intersect. Okay, hopefully that was a review. Now let's look at solving linear systems using substitution. Using substitution simply means we're going to look at one of the equations and we're going to say, I'm going to solve this equation for either x or y. And so you'll solve for y in terms of x, or you'll solve for x in terms of y, and then you'll plug that expression into the other equation and solve for the variable. It sounds more complicated than it is. All right, so let's do that. Let's look at both my equations. I like the top equation. It's much easier than the bottom equation, and I actually like solving it for y. If I want to solve this top equation for y, I simply have to move x to the other side, and I'm done. So we are going to solve the top equation for y. All right, anytime you want to move something from one side of an equation to the other, you have to use what is known as opposite or inverse operations. So ask yourself, what is the opposite of negative x? Because that's what we want to get rid of. Opposite of negative x is positive x. That means we add x to both sides of the equation. When we do that, we get y equals x plus 4. This is really helpful. Now I have one of the equations that is solved for one of the variables. So why is it so helpful? Well, now we have this expression, x plus 4, that's equal to y, but it's written in terms of x. Therefore, I can plug this x plus 4 into the second equation everywhere I see a y and solve for x. All right, let me show you the two equations we have now. If we look at the linear system with our rewritten equation, we have y equals x plus 4 and 2x plus y equals 19. Now we can take this new version of that top equation and plug x plus 4 in everywhere we see y down here. Let's see how helpful that's going to be. We're going to take x plus 4. We're going to substitute it in for y into the second equation. So I only see one y. That's fine. So I'll put x plus 4 in right there. My new equation is 2x plus x plus 4 equals 19. The reason this is helpful is because now I have an equation with only one variable. I can't solve for two unknowns, but I can solve for one unknown. So now I can take this equation and solve for x, and that's exactly what we're going to do. Okay, there's nothing that you have to distribute. Remember, when we're substituting in, we always put the expression in parentheses, make sure we distribute if we have to, but there is nothing we have to distribute simply because nothing was multiplied by y. So we're going to combine like terms. 2x plus x equals 3x, and then we'll just bring down the 4. So we get 3x plus 4 equals 19. All right. Remember, we're solving for x. What do we do to get x all by itself? We take care of anything added or subtracted first. We want to get rid of this positive 4. What's the opposite of positive 4? Negative 4. So we subtract 4 from both sides of the equation, and we are left with 3x equals 15. We still have not gotten x alone. X has a 3 that is multiplied to it. What is the opposite of multiplying by 3? Dividing by 3. 3 divided by 3 is 1, leaving me x. 15 divided by 3 is 5, telling me x equals 5. Now I can take this value for x and plug it in to either equation to solve for y. But I need more room if I'm going to do that. Okay, so now we know that x equals 5. We're going to plug that value into the first equation and get the value of y. So our first equation, remember, is y equals x plus 4. Could you have plugged it into the original equation, negative x plus y equals 4? You absolutely can. But I'm just going to plug it into this equation. So y equals x plus 4 is going to become y equals 5 plus 4, which is going to be y equals 9. Now I know that x equals 5 and y equals 9. Remember, solutions to linear systems are the point of intersection. So we are going to write those solutions as a coordinate point. So our answer is 5, 9. Be very, very careful to put the 5 in the x coordinate position and the 9 in the y coordinate position. We are now going to check our solution into the original system. Here is our original system. Substitute 5 in for x, substitute 9 in for y, and let's check. Let's start with the top equation. Negative 5 plus 9, so negative x, x was 5, plus y, y was 9, equals 4. Negative 5 plus 9 is 4. That checks. Next equation, 2x plus y equals 19. 2 times 5 is 10, plus 9 is 19. That answer checks. All right, so that's substitution. The steps you're going to use. Solve one of the equations for either of the variables. Then you're going to take that new expression for that variable and plug it in everywhere you see that variable in the second equation. Then you're going to solve for that variable. You're going to take that value from step 2 and plug it in for its variable in the first equation and solve for the other variable. And then you're going to check your solution into both equations. Remember to check both equations. If it works for one and not the other, it does not work. All right, when is substitution the most effective method? You can always use substitution, for sure, and some people only use substitution. But substitution is best when the system contains an equation that's actually already solved for one of the variables. So if I saw a system like this, where I saw x already solved for, I have x equals negative 3y plus 1, I would use substitution for this without a doubt. Okay, the first equation is already solved for x. I don't need to rewrite one of the equations, so I've literally eliminated one entire step. So let's go ahead and solve this one. We have x is already solved, right? We have x equals. We have an expression in terms of y that's equal to x. So we're going to start by substituting negative 3y plus 1, the value for x, and we're going to plug it into the second equation everywhere we see an x. We only see one x, so we'll only plug it in once. Be very careful. Negative 3 is multiplied to x, so we will have to distribute when we substitute in. When you substitute negative 3y plus 1 in for x, be sure to put it in parentheses. Do not forget your parentheses. If you don't distribute correctly, guaranteed to get the wrong answer. So let's distribute. Negative 3 times negative 3y is positive 9y. And here's the part people forget. Multiply that negative 3 times that 1. So what do we get? We get 9y, that's negative 3 times negative 3y, minus 3. Negative 3 times positive 1 is a negative 3. Bring down my negative 3y equals negative 15. All right, now we'll just clean this up. 9y minus 6y is equal to 6y. Bring down my negative 3, didn't do anything with that. Now I want to solve for y. I have to get rid of this negative 3. What is the opposite of negative 3? The opposite of negative 3 is positive 3, so add 3 to both sides. We get 6y equals negative 12. Now, y still isn't solved for, right? We don't have y equals. We have a 6 multiplied to y. The opposite of multiplying by 6 is dividing by 6. So divide both sides by 6. We get y equals negative 2. All right, so now we know y. We can actually take that value and plug it into either equation and find the value of x. I'm going to plug it into the first equation because the first equation has x already solved for. It's much nicer to plug into. Could you plug into this equation? Absolutely. All right, so we have x equals negative 3y plus 1, but in for y, we're going to put negative 2. So we get x equals negative 3 times negative 2 plus 1. Negative 3 times negative 2 is positive 6. So x equals positive 6 plus 1, x equals 7. Remember, now we know y is negative 2, x is 7. The solution is the coordinate point 7, negative 2. Are we done? Not really. We have to check. I mean, technically we're done, but we really have to check our solution. So we're going to check the solution 7, negative 2 by plugging 7 in for x and negative 2 in for y. Let's look at that first equation. X equals, so 7 equals negative 3y. So negative 3 times negative 2 plus 1. We keep going. Negative 3 times negative 2 is positive 6. 7 equals 6 plus 1, 7 equals 7. Perfect. Let's check the second equation. Negative 3x, so negative 3 times 7, minus 3y, so minus 3 times negative 2 equals negative 15. Be careful here. This is a negative 21. This is a positive 6. You could say negative 21 minus negative 6, but it's really just a positive 6. When you do this, negative 21, negative times positive, negative times negative, positive 6, equals negative 15. Negative 21 plus 6 is negative 15, and we are done. The solution checks. Hey, that's substitution in a nutshell. If you still have questions, you should be subscribed to our YouTube channel. Send me those questions, and I'll make you a custom video solution. Till next time, Math Hoppers, take it easy.